Right, so in this lesson, we're going to talk about the exact value of sine, cos, and tan. Before we do that, let's have a quick recap of the sine and cos on the unit circle. We can see the angle is right here, theta. Okay. Now, whatever the vertical value is, that will be the sine values for theta. And the horizontal value, that will be cos of theta. So in some way, if you think about, let's say I have the angle is sine 120 degrees. If I want to know where they are on the unit circle, think about I have 0 degrees here. If I go this way, it's the positive direction, and I'm going to mark 120 degrees. So that is about 120 degrees. Okay. Now the psi is the y value. So if I project this on the y axis, so you can see that distance here is sine of 120 degree. Okay, so where cos 120 degree? So cos is that distance here. If you project it on the axis, so this whatever that is going to be negative, as you can see, okay, it's on opposite direction. So that will be cos of 120 degree. All right. Now we're going to learn how to find the exact values of the special angles 0, 90, 180, and so on. So let's say I want to find what is sine of 90 degrees. Um, 90 degrees is that much, right? So that's 90 degrees. Now sine is the y value, and you can see how long that is. And they tell you it's a unit circle, so of course the y value equal 1. Now, cos, if I'm asking to find cos of 90 degrees, 90 degree, and we say it's right here, right? Because a corner of a circle. Now, the y value is 1, is a sine value, and cos is the x value. So if you check it on the x-axis, you can see cos of 90 is 0. So what about tan? Tan of 90 degrees is sine of 90 divided by cos of 90. Sine of 90 equal 1, cos of 90 equals 0. 1 divided by 0 is undivided. Okay. All right. And similar to that, you can do for the other side as well. Now, we're going to pick some of these examples to do together. Let's say this time I want to do, um, let's say I want to do 55 pi, for example, 10 of 55 pi. So if I draw a unit circle, so where 55 pi? So you have 0 degrees here. Pi is 180. So that is 1 pi. And if you go and again, that's 2 pi. And then if you go again, that's 3 pi. And then 4 pi on this side, continue. So you can see all the odd number pi on this side and all the even on the other side. 55 is an odd number, so 55 will be on the left side, so which is here. Okay, so 10 of 55 will be sine divided by cos. So you can see sine, so 10 is sine divided by cos. Sine is the y value, which is 0. And cos, you can see cos is -1. So 0 divided by -1 is 0. Okay, so 10 of 55 pi will be 0. So technically any angle on this side or any angle on the other side here, then we're going to have 10 equals 0. That's the quick shortcut. Now, let's say if you want to do a negative angle, cos of -2, you just need to go in the opposite directions. So you can see I have 0 degree here. -2 is -90 degrees. So I have to go this way now. So now I go about -90 degree. Okay. Now cos, so it's here. Cos is on the x-axis. And you can see as you project it on the x-axis, cos is 0. So the answer is 0. Now, how can we find the exact values of other angle? So this table, sorry, this circle summarized for you pretty much the whole thing. You have 0 degree here. As you go up, it's increase 30, 45, 60, and so on. And what does the point represent? The point is x and y, as you know. So x is the cos and y is the sine. So if I'm looking at, you can see this point here, which is 30 degrees, right? So x is root 3 over 2, and x is the cos value of the angle, which is, we call that theta. So cos of the angle theta, cos of 30 will be root 3 over 2, okay? And a half here represent the y, and the y is sine of theta. So sine of 30 is 1/2. All right, and similar for other angle. So as you see in this quadrant here, you can see cos of 240 degrees is negative 1/2, and sine is negative root 3 on 2, which is, if you think about on the x-axis here, negative 240, if you project it on the horizontal, this is about negative 1/2. And vertical, if you do it this way, this is about negative root 3 over 2. All right. Now, if you prefer to memorize in the table, that's okay too. And we're going to learn how to find the exact value using either methods. Okay. Now, let's say you want to do cos of 5/4. I'm going to show you two methods. Our first thing we have to do is pi over 4 is 45 degrees, right? Because 180 is pi divided by 4. That gives you 45 degrees. Now, because you times by 5, so 45 times 5, that is a 225. So we're looking for cos of 225. Okay. Now, the second step, if we're going to find reference angle. So our angle, the angle in quadrant 1. So one of these angles, 0, 30, 45, 60, 90, what we call that reference, because we want based on that to find the answer. So if we draw it out, okay, so 225 is here. So the angle that opposite to 225 in quadrant 1, we call that reference angle, which is, so you can see this is how much the left over here is from 180 to 225, so 45 degrees. If you take away them, so that's also 45. So the reference angle is 45. The quicker way to do it basically is on way that. It's on way pi over 4, which is 45 degrees. Okay, that's quicker. Now, step 3 is you're going to use ASTC, or if the sorry, the all positive in the second quadrant, only sin positive, on the third quadrant, only tan positive, and only cos is positive in the fourth quadrant. If you're confident, you don't have to use that. If you know in this quadrant, cos is positive or negative. So it's in quadrant 3, which is letter T. So letter T means cos will be a negative. So I know that cos 225 will be negative cos of 45. And I know the cos 45 is root 2 over 2. So I know the answer will be negative root 2 on 2. Okay. Now, let's say you want to do, let's say this time we're going to do a bigger angle, negative 25 pi over 6. And sometimes it's really hard to convert to degree. So how do you do that? Now, 25 pi over 6, you can't simplify further. So you can easily identify the reference angle here, which is 180 divided by 6 is 30 degrees. So you know that the reference angle is 30 degrees. Okay, now I don't want to go 25 times 30 because it's too much effort. Okay, I can, but I don't want to. So how do we break them up if the angle is big? What we do is we do division. Break them up. 25 pi gone to 6. If you do mixed number, 25 gone to 6 4 times, 25 gone to 6 4 times, and remainder 1. So 25 pi and 6, you can break it up as 4 pi and 1 pi over 6. Okay, that's how we think about it. So you go 1 pi, 2 pi, 3 pi, 4 pi, which you go back to the origin, and you plus pi with 6, which is 30 degrees. So technically, it just ended up here in the first quadrant. So the position of 30 degree is also next. So I should go the other way. Um, because the angle is negative, you need to go backward instead. So negative, I go 1 pi, 2 pi, 3 pi, 4 pi. So up to here I have 4 pi, and I have to go another pi over 6, right? Because that's the remainder. So you end up here. So this is how you know it's in quadrant 4. So 25 pounds here. So in this quadrant, 10 is negative. So I know it will be negative 10 of 30 degrees, which is negative 1 on root 3. Okay. All right. This is the last thing of today's lesson, which is to simplify using supplementary angle. So you expected to do simplify an expression like that. Now, if you look at this circle here, you can see. So this is the x-axis. This is the y, as we say. Now, theta is the angle, right? On the opposite side is pi minus theta. So you have pi here. And if you go backward by theta, you have pi minus theta. And from pi, if you plus another theta, you would have pi plus theta. And the other quadrant, if you go one circle, that's 2 pi. And if you go backward by theta, you will have here 2 pi minus theta. Okay. Now, how do we simplify this? To simplify, if we're looking for example, sine of 2 pi minus theta, which is here, right? Sine is a y value and the angle is here. So we want to know the vertical distance here. So the vertical distance here is also the vertical distance of the other angle, which is sine theta, as you can see. So because both of them have the same vertical, so you can see sine of pi minus theta is the same as sine theta. Okay. Oppositely, if I do cos of pi minus theta here. So pi minus theta here, I'm looking for cos. So cos is on the x-axis. So you project it on the x-axis. That represents cos of pi minus theta. Now you can see it's negative because it's on the negative side, right? So that distance, if we talk about distance, that distance is the same as that distance here. But this distance is positive. And this distance is the cos theta value because on the x-axis. So therefore, cos of pi minus theta is negative cos of theta. So with the same logic, we can do for 10 as well and for other angle too. Okay, so how do we simplify one of these, something like that? Now, if I do sine of pi minus theta, one way is I can look at this here. So sine of pi minus theta is the same as sine theta. They already give me that. So I know sine of pi minus theta is simplified as sine theta. And sine theta is 0.4. So I know the answer is 0.4. Okay. How do you do without looking? So without looking at this circle and draw by yourself. So let's say I'm going to do um, J, tan of pi plus alpha instead of r theta, just alpha. Okay, so I want to simplify. So you can see I want to simplify is either plus or minus. I don't know. It could be either 10, and I just want to simplify to alpha. That's that's for sure. Now I have to determine either plus or minus. So if I draw the unit circle out, let's say alpha in quadrant one. Okay. So pi plus alpha, alpha here, pi plus alpha will be in quadrant three. So with 10, in this quadrant, 10 is letter T. In this quadrant, 10 is positive. Therefore, I'm going to pick a positive answer. So let me just delete the negative. So positive. And then 10 of theta, sorry, 10 of alpha is, you can see that here, 1.2. So the answer is 1.2.